Hello guys. So in this session we are going to discuss about sensitivity. Yeah, it's really very beautiful term to understand. So let us talk about sensitivity. Actually, what do we mean by sensitivity? Physical interruption. You should try to get the physical idea. Sir, what do we mean by sensitivity? Very simple, very simple. The thing is, now I have a system. This is a system. If the system we are passing some signal, right? So let me demonstrate in an extraordinary way. Listen. For example, I have a block here, right? I have a block here. Now I would like to know, that is, I have a tank here. I have a tank. Now this tank is getting filled by a pump, right? So there is a valve. With the help of valve, we can fill this tank, right? So this is going to be the input for this system. Similarly, there is one more pipe here, right? This is outlet valve. From this outlet valve, or with the help of this outlet valve, we can collect the water. Now, apart from this input valve and output valve, assume there is one more leakage pipe. There is one more leakage tank, right? But I did not notice this. Now, here my question is, because of these disturbance, because of this leakage, there will be changes in the water level. Now the thing is, I would like to get the changes in my output response. Initially, if there is no this leakage, if you don't have any leakages here, whichever the water that we are conserving here, that you can consume here. But the problem is, because of this leakage, the amount of water level is going to be reduced in the output. Now the question is, sensitivity means how much percentage, in percentage, how effectively my system output response is getting affected due to this leakage pipe. Or in that way, in the same time, we can give the answer. Sir, if input water, there will be some leakages. If the leakage is the output, what percentage changes? If the leakage with respect to input, what is the percentage changes? What is the response or what is the sensitivity of my system? Or in the tank, the problem, the tank level, the holes will be created. So, the percentage change in the output water level because of the problems or issues in the tank or in the system, right? So, let us take what we have understood. So, sensitivity in the sense how effectively your system parameters or outputs are getting affected due to some unwanted disturbance or due to your reference signal or due to your system, whichever the question, some common type of questions will be asked. So, that is the sensitivity of the system. I said open loop systems are not sensitive. Why it is not sensitive? Though there is some changes here, you are unable to predict. Na வீட்ல ஒரு tank இருக்கு, tankல ஒரு small leakage இருக்கு அப்படினா நீங்க அத போய்ட்டு நீங்களா வந்து tank வந்து நல்லா இருக்கா அப்படினு போய் சுத்தி பார்த்தா தான் you can test. You will come to know, okay, there is some problem in my tank. அது வந்து உங்களுக்கு தெரியும். Small leakages. I'm talking about small leakages. Suppose if you have a closed loop system, then what will happen? When the moment there will be hole வந்து வரும்போது என்ன ஆகும் அப்படினா suddenly you will get an alarm. You will get a message, sir, there is some problem in your tank, right? Some leakage is going. Now what will happen? So reactor now power plant closed loop system will be there, right? That system is completely closed, right? Reactor you might know, right? We are generating nuclear power plant, that is we are planting nuclear power plant and we are generating the electrical power with the help of nuclear power plant, right? Adukulla reactors are completely closed loop. See, if there is any small problem occurring in your reactor, then what will happen? It will create a big issue in your system. So it is highly sensitive. The parameter variations inside the block are highly sensitive. Each and every second we have to test the pressure of the system and temperature level, right? Everything will be tested, right? But time to time. That is very important. That type of systems are closed loop system. In that case, what we are going to do? We are going to test the sensitivity, parameter variations in the output, reactor output with respect to input, with respect to system, with respect to temperature, with respect to humidity, with respect to pressure. That is called the sensitivity. How effectively I am getting affected because of you. How effectively you people are getting affected because of me. Now you are attending the classes here, so your knowledge is slowly growing up, yes or no? So the parameter changes in your brain level with respect to my knowledge. That is my input here. I am giving the input and you are collecting the output. So what is the parameter variations in between us? How effectively your brain is responding, output response, right? In your exam with respect to my input signal, that is called sensitivity. That's all, right? So now we are going to learn it. And once again, anyway, if I will talk about sensitivity or anything, I said control system, it's not a separate subject to learn. It is our physical life, right? Each and every components examples are here control system only. You can take any one component, you can play with your control system. That component is called a system. You can take electrical machines, power system components. In your home, you will have many machines, many motors, many systems. Your mobile, your hand, our body, our heart, our respiration system. You can take anything. This universe, this home, this that is animals. Any other component there you can find some sensitivity. There you can find some responsibility. So control system, it's not a separate subject to live on. It's a physical life, right? You can interrelate with your physical components and we can deal. That is, you can play with your system, right? So anyway, we are in control system. As our responsibility in our exam point of view, we have to generalize how to calculate the sensitivity of any systems. Yes or no? Yes. Let us design. Right? In our cases, there universally we are just designing two type of system. One is open loop system and another one we are going to consider closed loop system. So it is depending on the application. In your home, if you take your fan, that is open loop system. Yes or no? Why? Because fan, can you that is, are you sensing the speed of your fan every time? No. That is not that much variations. Lifetime will be known. Once வந்து நம்ம ஃபேன் வந்து வாங்கி போட்டுட்டோம் அப்படின்னா அந்த லைஃப் அதாவது லைஃப் டைம் முடிகிற வரைக்கும் அது ரன் ஆகிட்டே இருக்கும் வீட்டில், அவ்வளோதான். கரெக்டாக? ஸோ தட் இஸ் ஓப்பன் லூப் சிஸ்டம். We are not each and every time while switching on the fan, we are not sensing the speed with the help of tachometer. So that is open loop system and that is highly stable only. Suppose if I have a reactor, take your nuclear power plant. If I have a reactor, it is highly over time on the reactor you operate பண்ணும்போது temperature created by the reactor is very high. Now we need cooler. Yes or no? நீங்க வந்து power plant engineering cooler அப்படிங்கற ஒரு term வந்து நம்ம பார்த்திருப்போம். So in that case, I have to measure the temperature. Now to reduce the level of the temperature, we are passing the cooler. With the help of cooler, we are passing the water such that temperature level will be maintained. Yes or no? So that is called closed loop system. So the sensitivity parameter variations with respect to the input, with respect to temperature, with respect to humidity, with respect to that is called closed loop systems. So what is our responsibility? We have to generalize any systems. Okay, only two type of systems are there. One is open loop, another one is closed loop. In closed loop, these are two types. One is positive feedback system, another one is open loop. Negative feedback system. Okay, some things are there, some difference will be there between positive and negative feedback system. Slowly we will tackle, no problem. In analog electronics, in control system, only we are going to deal with these two peoples only. So again and again we are going to talk slowly whichever the things that I have given, that I have been differentiated in between your positive feedback and negative feedback, that will be tackled one by one at the time of corresponding topic வந்து நம்ம பேஸ் பண்ணும்போது அது automatically tackle ஆகும். So you no need to worry. Just what I can say is slowly inject the poison. Yes or no? Yes. Let us see. When the moment we are talking about, so the conclusion is sensitivity will be defined as percentage changes in your output or any variable, right? So percentage change in any variable. For an example, listen, let me define like this: sensitivity of A with respect to B. If I define like this, actually what is the meaning of this one? In the in our exam point of view, sensitivity will be generally defined as yes. Right, in the power we are keeping A, in the component here we are keeping B. So here we can write like this: sensitivity of A with respect to B. Here we have two quantity. So it can be generally defined as percentage changes in A with respect to percentage change in B. That is generally how we are defining the sensitivity of any system. Okay, I hope now you might get the clear idea. Let us extend our discussion. Now, when the moment we are discussing about our control system, in our control system, these are the two type of control system. One is open loop control system. In our open loop control system, we have only one block. That block has the transfer function g of s, whereas the input signal for this block is going to be r of s, whereas output signal for this block is going to be c of s. Now the question is, what is the overall transfer function of this system? Right? In this case, we can simply call it as overall transfer function. For that, I need output first. Right? In this system, output can be written as c of s can be simply written as g of s into r of s. Now from this, I can write the ratio in between c of s and r of s will going to be g of s. Yes or no? This is called transfer function of open loop system. So transfer function of your open loop system is nothing but g of s. Now I would like to know, for an example, you are allowed to ask the question. That is, I am asking the question, right? The question is, find out the sensitivity of your transfer function t with respect to g for your open loop system. Right? This is the given system. Right? Some practical system will be there. Okay, we are generalizing. Right? What is our responsibility? We have to generalize the system. Right? So generally, if the question is, find out the sensitivity of the overall transfer function of your open loop system with respect to g. What will you define? So it can be written as percentage changes, right? Percentage changes, right, in T from its overall component divided by percentage change in G. That is how we are generally writing the expression for this component. Now how will you generally idu neenga further explain பண்ணுவீங்க. See, this component also can be written like this: percentage changes in A, percentage changes in A divided by percentage changes in B. In the sense it can be written as the actual change in A divided by total value. That is how we are finding the percentage. Yes or no? How much na evlo change aayirukku with respect to from the total value, right? Divided by percentage change, that is the changes in B from the total value. Percentage, right? For that we are multiplying it by 100. Of course here also we are going to multiply by 100 in percentage, right? 100 getting cancelled out. In resultant this component can be written as dou A by dou B into B upon A. So that is how we are writing the generalized expression for sensitivity of A with respect to B. And if you observe one more thing, numerator also, right? Numerator also written in percentage, denominator also written in percentage. So percentage getting cancelled out. In resultant this formula, this sensitivity will become unitless quantity. Your sensitivity will become unitless quantity. Getting me? மேல இருக்க டேர்ம் நம்ம பர்சன்டேஜ்ல எழுதிருக்கோம், கீழ இருக்க டேர்ம் நீங்க பர்சன்டேஜ்ல எழுதுறீங்க. So percentage getting cancelled out. For an example, if you are finding the variations in your impedance, right? Output impedance with respect to input impedance or some other variable, then what will happen? அப்ப நீங்க எழுதும்போது output impedance also will be in home, input impedance will also be in home getting cancelled out. In resultant sensitivity will always become what? Unitless quantity, right? So should try to keep it in your mind. See, some small thing we are learning, and some don't think too much. So in the same way, when I am writing the expression for sensitivity of the overall transfer function of a open loop system with respect to G, let us see how to write this one. How will you write percentage change in G, right? The changes in T with respect to overall value divided by the changes in G with respect to overall value. Of course in percentage 100 into 100 divided by 100 is getting cancelled out, I know. So this formula can be further written as dou T by dou G into G upon T. So that is the generalized formula, right, to obtain the value of open loop transfer function, that is sensitivity. Now what we know, just now we saw in our open loop system T of S and G of S both are equal. Yes or no? So it can be further written as dou T can be replaced by dou G into G upon T can be replaced by G. Dou T will become dou G, T will become G. Why? Because T is equal to G. For our open loop transfer function, G of S known as T of S, right? So what I have understood, that is going to be 1%. That is 1, and value is 1, right? So the conclusion is percentage changes, the sensitivity of your overall transfer function with respect to the forward path gain will going to be 1. Are you getting me? So what it means here, actually what it means here, you have to understand, right? Actually நம்ம எப்படி கால்குலேட் பண்ணோம் அப்படினா, see, அப்ப நம்ம எப்படி எழுதலாம்? See, let me rewrite the expression. Should try to understand. In your examination you are allowed to ask me question like this. Suppose the question is from this, what I can write? The percentage changes in the overall transfer function with respect to G. இது நம்ம எப்படி எழுதுவோம்? Percentage change in T, that is overall transfer function, divided by percentage change in G should be equal to 1. It means the percentage change in T, the percentage change in overall transfer function will be equal to percentage change in G, right? So percentage change in G, that is the general relation between open loop transfer functions. So what we have understood, if we have open loop transfer function பொறுத்த வரைக்கும், right, overall transfer function is what? Overall transfer function is T, அதுதான் நம்ம G அப்படினு சொல்றோம், right? அப்போ ஒரு forward path parameter பொறுத்து நம்ம sensitivity எவ்வளவு இருக்கு அப்படினு நம்ம டெஸ்ட் பண்ணி பார்க்கறோம் அப்படினா, in my transfer function or in my system, right, உங்களோட open path இருக்குல G, அதுல எவ்வளவு changes வருதோ same amount of changes we can observe in the output of the system. Are you getting me? So for an example, provided assume your input is constant, R of S is going to be constant, input is constant. Now the question is, you are requested to percentage changes in the output, when there is a changes in your black G. Now what will happen? Usually C of S can be written as G of S into R of S. Yes or no? If R of S is constant, then what are the amount of production, that is உங்களோட gain ல வந்து எவ்வளவு changes வந்திருக்கோ same changes you can observe at the output side. Why? Because R of S is going to be constant. I am repeating once again. Actual question வந்து என்ன கொடுக்குறாங்க அப்படினா, ஒரு open loop system இருக்கு. அந்த open loop systemல சடனா என்ன இருக்கு அப்படினா, blank குள்ள இருக்க சிஸ்டம்ல வந்து ஒரு 10% வந்து ரிடக்ஷன் ஆயிடுச்சு. அப்போ அவுட்புட்ல என்ன சேஞ்சஸ் வரும் அப்படின்னு கேட்டாங்கன்னா சேம் பர்சன்டேஜ் யூ கேன் அப்சர்வ் in the output side because output and the system are directly proportional. Are you getting me? So that is how we are solving, that is how we are testing the sensitivity. Guys, yes, I have given some theoretical relations here, but practically you should know. Sir, I have a black, I am a black. You are giving the input here, I am receiving the output here. Suddenly, if your input is maintained as constant, but in my system there will be some changes. Because of that, my output is started. What will happen? If there is any changes in your output, directly your output also. If there is any changes in your system, directly your output also getting affected. Are you getting me? Yes. Now we can simply test. This is my input signal. I am giving input here, right? It is constant, but my brain function is not working properly. Now what will happen? I am trying to write in my left hand. I am writing something. Now because of my malfunctioning, because of the malfunctioning in my brain, though I am giving proper input signal at this side, my system is not working properly. So because of the malfunctioning in the system, same percentage you will be faced. That is same percentage reduction will be there in your output side. So the conclusion is, in your open loop system, what is the variations, right? What is the parameter variations in the output with respect to system, or what is the parameter variations in the output with respect to someone that will be given. Generalized things will be generalized, right? G. Let us see. Let me take the closed loop system. Then you will get the very clear idea, right? See, the same way, whenever we are trying to find out the sensitivity of a closed loop system, for our closed loop system, let me take closed loop system in the sense we know, for our closed loop system, our overall transfer function, right? Overall transfer function is, let me have a G here, of course. Here we are going to provide our comparator, yes sir. So this is the point where we are going to keep our H, yes. And this is the point where we are going to take our input back, right? So that is feedback path, sorry. So that is H. And here for an example, I am taking negative feedback system and we are injecting positive feedback. That is positive. Reference signal is going to be positive R of S and this is going to be C of S. Yes sir, that is the generalized block of our closed loop system with negative feedback. Yes, that is beautiful, right? Now we all know what is the transfer function of the closed loop system. Already we saw how to build the transfer function of the closed loop system. That was simply written as G upon 1 plus G into H. Is there any mistake? No. I did not make any mistakes. Now the question is, what is the percentage or find out the sensitivity of the overall transfer function of this system with respect to the changes in the forward back block. If you observe the closed loop system, I have a system in the forward back. I have a system in the negative back, right? Now my question is, find out the overall response. That is overall transfer function. Find out the changes in the overall transfer function. Find out the changes in the overall transfer function with respect to the parameter variations in the G. இப்போ ஜியில் வந்து சடனாக ஒரு சேஞ்சஸ் வருது அப்படின்னா அந்த சேஞ்சஸ் வந்து எவ்வளோ பர்சன்டேஜ் வந்து உங்களோட அவுட்புட்டை வந்து அஃபெக்ட் பண்ணுது. பிகாஸ் இட் இஸ் க்ளோஸ் லூப் சிஸ்டம், இட் இஸ் நாட் லைக் மை ஓப்பன் லூப் சிஸ்டம். அப்போ நீங்கள் அதை எப்படி டெஸ்ட் பண்ணுவீங்க? எஸ், ஐ ஹவ் அ ஜெனரல் வேர் அண்ட் ஐ நோ ப்ரொசீஜர். How will you write the percentage changes in the T? The percentage change in T can be written as variation in T with respect to overall transfer function divided by variation in G with respect to overall gain. Clear? So it can be further written as dou T upon dou G into denominator will be numerator, so that is going to be G by T. Wow, that is perfect. Now we have to find out the value of dou T by dou G. How will you find? See, this is T. Let me write. I know that is Laplace. I am just writing T. This is T. I would like to know the value of dou T by dou G. How will you find dou T by dou G? In the sense, you have to differentiate this function with respect to G. Of course, in the denominator and the numerator we have G, right? So we have to go to U by V method. So U by V can be written as U dash V minus V dash U upon V square. That is the general formula. Just use this formula to differentiate the function. First step, I have to keep U dash G with respect to G. I am differentiating this function with respect to G only. So G is going to be 1 into V. V is denominator. So denominator will become 1 plus GH. Now minus V dash. We have to differentiate this function with respect to G, right? We have to differentiate this function with respect to G. So if I differentiate, 1 will going to be 0. I have to differentiate denominator equation. G about the differentiate, 1 will be 0. G will become 1. So you will get what? H into numerator function is what? That is U. U is going to be G, whereas in the denominator overall function is going to be 1 plus GH whole square. Clear? Now if you reduce this function further, what will you obtain? 1 plus GH. If you open up the bracket, it is going to be minus GH upon 1 plus GH whole square. 1 plus GH whole square. Now carefully observe, GH getting cancelled out. So the value of dou T by dou G is going to be 1 by 1 plus GH whole square. Just take the values and substitute here. Dou t by dou g can be replaced by 1 upon 1 plus gh whole square into g upon t can be replaced by, that is t can be replaced by g upon 1 plus dh. So what we have understood here, g getting cancelled, 1 plus gs is getting cancelled out, that is 1 plus gs whole square divided by 1 plus gh. In resultant I am getting 1 by 1 plus gh. Clear? What we have understood from here, the parameter, that is the sensitivity of the overall transfer function with respect to the forward path gain is this much. Clear? So there are two people here, G and H. Now you have to test. You can test in your exam. The value of G will be given and the value of H will be given, right? Now the question is, find out the sensitivity of the overall transfer function with respect to the forward path gain G. First find out the value of 1 by 1 plus GH. Clear? And then the percentage changes in G will be given, right? The percentage change in G will be given. Let me reduce this expression further, so that you will get the clear idea. Now you know how to develop this equation further. So the sensitivity of the overall function, actually it can be written as St by G. Again, how can you write this expression? It can be written as percentage change, right? Percentage change in overall transfer function with respect to the percentage change in forward path gain G. That should be equal to 1 upon 1 plus GH. Now from this we can write, that is percentage change, right? Percentage change in the overall transfer function should be equal to 1 upon 1 plus gh into if I pass this term, that is going to be percentage change in G, percentage change in the forward path gain, percentage change in the forward path gain G. See, that is how we are finding the changes in your overall transfer function with respect to the changes in your forward path gain. Clear? I hope you are getting the clear idea now. In the same way, suppose we have one more black, forward or black, feedback path or black. Suppose if my overall transfer function is varying with respect to feedback path parameter h, then how will you find out the sensitivity of the system? Very simple, right? Let us see how to do that one, right? In that case, once again, take your overall system, right? Actually, the question is, find out the sensitivity of the transfer function with respect to the changes in the feedback path parameter variation, right? So feedback like the black changes how effectively, how much percentage that feedback path parameter influencing in our system, or how much percentage it is affected, right? Your system is, right? You have to find out that. The parameter changes, right? Sensitivity of my overall system, overall transfer function with respect to the feedback black, right? How can we write as, that is how will you write this one? Percentage changes in T with respect to T upon percentage changes in H with respect to overall H, right? So it can be further written as dou T by dou H into denominator will be numerator, it can be written as H by T. Just now we saw for a negative feedback system, transfer function T can be written as G upon 1 plus GH. Wow, that is perfect, right? Now what I have to do, I would like to conclude one more thing. From this, if I extend my discussion, I would like to get the value of dou T by dou H. Now calculate the value of dou T by dou H. If you estimate the value of dou T by dou H, take your overall system. How will you find? Further, once again, H in negative term, only one term, that is in the denominator. For an example, I would like to get the value of G. G will be constant. In the 1 plus GH, it will become 1 plus GH whole inverse, right? We can write like this. We can write like this, and then you can differentiate further with respect to H. If I differentiate this equation, see, very simple. Just it can be written as G dot 1 plus GH whole inverse. We can write like this. Now you can differentiate G 1 plus G whole inverse differentiate, you will get minus 1 into 1 plus GH whole power minus 2. So it can be further written as G upon, that is minus G, minus 1 into G upon 1 plus GH whole square. Clear? So that is the value of dou T by dou H. Anyway, let me pass it to the denominator. For your understanding, I have written in the numerator, its actual value is what? G upon 1 plus GH only. Now we know the value of dou T by dou H. Next, what I am going to do? Okay, sir, I understood this all things. Now getting back to the system, so the sensitivity of the overall transfer function with respect to the feedback path parameter is going to be dou T by dou H. What is the value of dou T by dou H? Dou T by dou H can be written as minus G upon 1 plus GH whole square into, right, into H by T. H is here, T is how much? G upon 1 plus GH. Now what we have understood, okay, 1, that is 1 plus GH whole square divided by 1 plus GH is getting cancelled, 1 G is getting cancelled out. So from this I can write, let me reduce the system further, right? See, actually you should try to understand, right? Control blocks all are practical systems only, but we are generalizing, we are going with general systems, right? We are trying to analyze, okay, one closed loop system will be there in the universe. There are, what I can say, some closed loop system, you can find some closed loop system, some open loop system. So I cannot generally take this is called a specific closed loop system, this is the one and only closed loop system will be there, not like that. In the entire universe, wherever you go, you can find out the open loop system. That is, the universe itself will have a closed loop system and open loop system. Yes or no? Yes, fine. So let us see what will happen here. So the thing is, percentage, that is the sensitivity change, that is the sensitivity of the overall transfer function with respect to the feedback parameter can be written as percentage change, right? So percentage change in T upon percentage change in H. Percentage change in H. So it can be written as, it should be equal to minus, what we have understood, minus, finally where is our answer, minus H divided by minus H upon 1 plus, is that correct? Yes, of course that is correct, right? So this is correct, 1 plus G into H. Now next thing, what I am going to do now, right? So now I would like to conclude few more things. I think I left some values here, what I have done. See, listen, while doing the internal differentiation, 1 plus G, yes, listen guys, here I made a small mistake, minus 1 is correct, just we are differentiating this function. In the numerator G into 1 plus GH whole power minus 1. இதை differentiate பண்ணினா minus 1 into 1 plus GH whole power minus 2. Internal differentiation, I left this term. In the GH நீங்க h பொறுத்து differentiate பண்ணா you will get one more G. So it will become G square. 1 G is getting cancelled out because I know this one. Already I have done it many times, right? So it will become minus GH only. So what I have understood here, I got something minus h divided by 1 plus GH, right? Listen guys, listen. Suppose if the value of GH is far away from 1, when the moment we are finding the product of G into H, if it is much greater than the value of 1, for example, G into H is 1000, whereas here I got 1. 1 plus 1000 will become 1101, that is 1001, right? But I know 1001 is approximately equal to 1000 only. So if the value of GH is very high, usually it will be like that. If you substitute that one, then this value is approximately equal to minus GH upon GH only. That is, we can neglect the effect of 1 such that it is getting cancelled out and the value is going to be equal to minus 1. It is going to be equal to minus 1. Now, what we have understood here, sir, the percentage change in overall transfer function with respect to the percentage change in G, with respect to percentage change in H is in negative. Are you getting me? So, what we have understood here, listen. Yeah. See, what we have understood here, so listen. So the sensitivity of the overall transfer function with respect to feedback parameter will become minus 1, right? So what we have understood from here, so the thing is, the sensitivity of the overall transfer function with respect to forward back gain, just now we saw that was became 1 upon 1 plus DH. Of course, even here also you can keep the condition, the product of G into H is greater than the value of 1. Practicalities, I am just talking. Suppose if the value of GH is far away from 1, under that condition, this function can be rewritten as 1 upon 1, that is G into H. Now, just compare. When we have a closed loop feedback, negative feedback system, when we have a closed loop control system with a negative feedback, just should get the beauty of this system here, right? So, what is the beauty of this system? Let us see. The thing is, in the feedback path, we have a parameter H, whereas in the forward path, we have a parameter G. Right? Now this is going to be my negative feedback, of course, and this is going to be your reference input, and this is my control system. Guys, listen, should try to get the physical meaning of this one, right? So in this universe, what we have understood, whenever we have a closed loop system, நம்ம ஜெனரலாக நம்ம யூனிவர்ஸில் இருக்க எந்த ஒரு காம்பவுண்டை நம்ம எடுத்துக்கிட்டாலும் அந்த காம்பவுண்ட் வந்து நம்ம ஃபீட்பேக் எடுத்து நம்ம டிசைன் பண்ணியிருக்கோம் அப்படின்னா, ஃபார் அன் எக்ஸாம்பிள், வாட் ஐ வுட் லைக் டு கண்ட்ரோல் மை பிரைன் சிஸ்டம் இஸ் a feedback system, right? What I can say, brain system is a feedback system in the sense. Now, is there any abnormal, நம்ம பாடியில் ஏதாச்சும் வந்து ஒரு டெம்பரேச்சர் வந்து ரைஸ் ஆகுது அப்படின்னா suddenly our body will send a signal to your brain so that sir நார்மலாக உங்கள் பாடியோட டெம்பரேச்சர் வந்து ஒரு நார்மல் லெவலில் இருக்கணும், ஆனால் இப்போ வந்து நார்மல் டெம்பரேச்சர் அதோட அதிகமாக இருக்கு, then what will happen again? Okay, okay, I understood there is some problem in my body, so I have to go. எனக்கு அந்த சிக்னல் வந்தோடனே நான் என்ன பண்ணுவேன், I have to rectify. So I will go and meet the doctor and I will put some injection and tablet and then so that I will become normal and I will try to reduce my temperature. That is called closed loop system. But you know, there is some complexity. For an example, due to some abnormal environment and sometimes because of the environment there might be changes in our body. Chuma understand பண்ணிக்கோங்க. Under that condition, again my brain is getting one signal. Your body will be in abnormal condition. So suddenly I think, oh, I had a fever now, I have to go hospital. I'm having fever now, I have to go hospital. But that problem came because of some environmental effect here. But my body is sending negative signal, right? That signal is what? Wrong signal actually. The signal is actually I don't have any fever. Because of the environmental changes here, my body temperature has been increased. But I'm getting wrong signal. You had a fever now. I'm thinking, oh, I'm having fever, I have to go hospital. Then I'm going on doctor testing and he put injection. Oh, yes, you are having a fever. Now what will happen? Again, it will affect my body because I don't have fever. Because of the environmental changes, my body temperature has been raised. It is not because of the fever. So because of the negative command, right? Because of the negative command, unwantedly I inject fever. That is unwantedly I am injecting injection, right? I am putting injection. That is for me. So and the spends adinukku thevallada ondadana. So my body is unwantedly affecting. So whenever you are having the feedback, there will be a problem of malfunctioning. At sometimes you might get negative feedback. Negative feedback at sometimes you may get some wrong signals, wrong feedbacks. So always if an conclusion enna kadichirukku appadina, the sensitivity or the changes in my overall transfer function, the changes in my overall transfer function with the changes in your forward path, gain is 1 by 1 plus dh. Under the changes in the overall transfer function of the system with respect to the feedback path parameter is negative. See that? So what it's include here? Conclude. Then the conclusion கொடுக்குது அப்படினா, if there is any changes in the feedback parameter, then there will be a negative reduction. Negative in the sense that there will be a reduction in your overall transfer function. Getting me? But I did not observe any case like that when I am going with the changes in your forward path gain. Getting me? Forward path ஏதாச்சும் gain வந்து reduce ஆயிருக்கு இல்ல increase ஆகுது அப்படினா, அதை நீங்க என்ன பண்ணிக்கலாம், இந்த ஃபார்முலா வச்சு நீங்க டெஸ்ட் பண்ணிக்கலாம். I understood something 1 by gh அப்படி நீங்க போடிங்க அப்படினா, you will get how much amount of percentage that will be changed in overall transfer function. Like that you will get some conclusions. But the problem is you should talk about the feedback path parameters here. ஆனா feedback path parameter வந்து நம்ம செக் பண்ணி பார்க்கும்போது, சார் forward pathல changes வந்தா some value I am getting, but I did not, that is you cannot conclude just with this without knowing the value of g and h. I did not, that is I could not make any conclusions about the forward path. இதுல வர changes ஆல overall transfer functionல என்ன changes வரும்ன்றத அவ்வளவு சீக்கிரம் நம்மளால சொல்லிட முடியாது just without knowing the value of g. But the thing is, when I am talking about the negative feedback parameter, I can conclude one thing here. What I have understood, if there is any change in the value of g, definitely if there is any changes in the feedback path parameter, definitely overall transfer function will be reduced because negative. My answer become negative. So that negative indicates definitely feedback path changes vanduchu appadina overall transfer function will be reduced. So when I am comparing the sensitivity of the overall transfer function with respect to feedback path parameter with the sensitivity of the overall transfer function with respect to forward path gain, இந்த ரெண்டு sensitivity compare பண்ணும்போது the sensitivity of the overall transfer function with respect to feedback path parameter is more sensitive than this one. That is the conclusion, right? So our system வந்து நான் என்ன சொல்றேன் அப்படினா, இந்த closed loop system பொறுத்த வரைக்கும் சார் forward path gainல இப்ப நம்ம நார்மலா ஆக்ட் ஆயிட்டு இருக்க ஒரு open loop system, இது வந்து ஒரு open loop system. இத மட்டும் பாருங்க தனியா, ரைட்? இத மட்டும் பாத்தீங்கன்னா ஒரு open loop system. இது ஏதாச்சும் ப்ராப்ளம் வந்தா suddenly there might be small changes like that. ஆனா இந்த feedback pathல ஏதாவது ப்ராப்ளம் வந்துருச்சு அப்படினா overall சிஸ்டமோட வேல்யூ என்ன அஃபெக்ட் ஆகும். அப்ப இவங்க ரெண்டு பேரை கம்பேர் பண்ணும்போது ஹ்ல வர சேஞ்சஸ் தான் ஓவரால் சிஸ்டம்ல அதிகமான இன்ஃப்ளூயன்ஸை கிரியேட் பண்ணுது. வெரி இம்பார்ட்டன்ட் டூ மார்க் क्वेश्चन. We can expect theoretical questions will be asked in your IAS exam and your interviews also, right? So when I am testing my system, feedback pathல வர சேஞ்சஸ் வந்து it is overall value டைரக்டாவே ரெடியூஸ் பண்ணுது அப்படிங்கறத நம்ம அப்படியே கன்க்ளூஷன் கொண்டு வந்திருக்கோம், right? So the parameter variations in the overall transfer function or the sensitivity of the overall transfer function with respect to the feedback path, this is severe one. Clear? Because that will reduce the overall value. That's all. So that is how we are finding the sensitivity in a general way of any closed loop system or any open loop system. Of course, any system generalized, right? So what we have understood from the sensitivity, that meaning, அதோட word என்ன சொல்லுது அப்படின்னா ஒரு சிஸ்டம் இருக்கு, அந்த சிஸ்டம்ல சம் டிஸ்டர்பன்ஸ் வருது, சடனா வந்து ஒரு டிஸ்டர்பன்ஸால அந்த சிஸ்டம் வந்து அஃபெக்ட் ஆகுது அப்படின்னா அந்த அஃபெக்ட் ஆகிற சிஸ்டம் அவுட்புட்டை எந்த அளவுக்கு அஃபெக்ட் பண்ணுது. கெட்டிங் மீ? ஐம் அ சிஸ்டம். இப்போ எனக்கு என்னோட சிஸ்டம் வந்து என்ன ஆகுதுன்னா சடனா வந்து ஃபீவரால வந்து நான் வந்து என்ன ஆயிடுச்சுன்னா ஃபீவர் அப்படிங்கிறது ஒரு அன்வான்ட் திங், அதனால நான் டிஸ்டர்ப் ஆயிட்டேன். இப்போ என்னோட டிஸ்டர்பன்ஸ் தான் ஐம் unable to continue the class, I'm unable to continuously take the class here. Then what will you do? You people are getting affected because output is what? You people are waiting for my class. But here I got affected by fever, I'm laying in the bed, I'm unable to continue the class. So that's a problem here. No, that is the sensitivity simply. So that is what I will told you. Control system, it is not a special or specific subject to take and deals with a separate topic. Oh, such a kind of topics are there, such a kind of machines are there. Not like that. Anywhere, right? All the components, existing systems are here what? Control system only. You can simply play with your system, right? Of course, in your examination, right, whichever the way that they are approaching here, you can go with the same approach. Clear? And the second thing is, at sometimes here what we saw, generally we saw, if there is any changes in G, then what we have to do? If there is any changes in H, then what we have to do? Generally, at sometimes some transfer function will be given to you. For an example, some function will be given like this: 1 plus s divided by 1 plus k times of s square. Some transfer function will be given like that, right? Now the question is, you are requested to, so this is the overall transfer function of a system, right? Now find out the sensitivity of the overall transfer function. Find out the overall sensitivity of the overall transfer function with respect to k. If it is given like that, then what you have to do? You have to transfer function t is given, it is given, right? So what you have to do? Just to find out the value of sensitivity of the overall transfer function with respect to k. How will you write? So sensitivity, percentage change, right? Percentage change in my overall transfer function with respect to percentage change in k. How will you write the expression further? So it can be written as dou t, changes in my t from overall value, right? Variation in the value of k from the actual value, right? So it can be further written as dou t upon dou k dot k upon t. Now we know the value of t, it was given here directly. Of course, TFS we know, that is Laplace we know. T directly can substitute here, but dou t by dou k is not known. Now take your transfer function just to find out the value of dou t by dou k from here. Just to differentiate this function with respect to k, find out the value of dou t by dou k. What will you obtain? It will become 1 plus s is constant because we are differentiating this function with respect to k. So what will you obtain? If I differentiate this function with respect to k, I will get, see, இது அப்படியே numerator கொண்டு வந்தீங்க அப்படின்னா this function will become 1 plus k s square whole power minus 1. If I keep it in the numerator, now you can differentiate by that minus 1 into 1 plus k times of s square in the power minus 2, right? After doing the differentiation, inner differentiation will give you one more s square. So this step further, right? So this value further written as, that means minus of 1 plus s, that is in the denominator, this value can be actually one more s square will be there. S square, we can keep this s square also in the numerator, but 1 plus k s square whole power minus 2 once again will be passed into the denominator. 1 plus k times of s square in the power we are going to keep 2. So that is the value of dou t by dou k. Now you can substitute this value here and t is given, right? T is this one. Once again you can pass. That is going to give you 1 plus k s square whole power 1, right? For your differentiation, I took this one to the numerator. Now you can directly substitute value here. T will be substituted. Dou t by dou k is known. That is substitute பண்ணீங்க அப்படினா you will get the overall. That is the sensitivity of the overall transfer function with respect to k. Clear? So that is how we are dealing with the sensitivity of the various systems, right? So in the next lecture, guys should try to practice, right? I will give some questions here. At the same time, here some questions are there, but I am not going to solve the questions directly because I would like to test your logic, because that is not a big thing. Whichever the data, that is whichever the procedure that I am following here, just with the procedure, just with the help of the procedure, you can solve your question. There are no new things to understand. See, whichever first question is find out the sensitivity of the transfer function with respect to someone. அவ்வளவுதான். யாரை பொறுத்து கேட்குறாங்களோ அவளை பொறுத்து ஃபார்முலா டெரைவ் பண்ணி just complete your derivation, you will get the answer. There are no new things to analyze here. Clear? So this is all about sensitivity of the control system. With this, I am concluding this lecture. In the next lecture, we are going to discuss about the beautiful concept that is called impulse response of the system. Right? Let's see in the next lecture. Thank you.